Okay, so good morning, ladies and gentlemen, and welcome to today's training. Today we begin with network implementation. You remember we are still going through the PDOI, plan, design, implement. So now we are on the implementation stage. We looked at how to do network planning. We then looked at how to do network design. And today we look at how to implement whatever we have designed in the previous phase. Now, I'll read the foreword. Project implementation indicates the operation process of delivering a project. The operation process of delivering a project. So, systematic management along with efficient process ensures a successful project implementation. So this document describes the project delivery process. Number two, what we call the risky operation implementation process. And lastly, it's also going to look at the engineer service standards. Now, the project delivery process ensures high efficiency of project management. So that's the project delivery process. The purpose is to ensure high efficiency of project management. Then risky operation implementation process is a guide to minimize the risks during the implementation, and the engineer service standards provide good vocational standards for engineers. So let's look at this. By the end of this chapter, you should be able to, Gaduri.
Upon completion of this section, you'll be able to comprehend the project delivery process, be familiar with the risky operational implementation process.
Yes.
Understand the engineer's service standards.
Okay, thank you very much. So let's begin with the project delivery process. Now, generally, the project delivery process can be defined as this. So the project delivery process, it specifies the requirements on the project implementation, management, and operation control, ensuring that the project is implemented based on the specified process. Now, the main purpose of having or the project delivery process in itself should ensure, number one, enhanced customer satisfaction, improved work efficiency, and as much as possible, should also reduce any risks that are associated with the project. So this is why we have to be aware and understand the requirement of the project and the implementation management and operation control, so that we can ensure that the customer is satisfied with how we are handling the project. We can be efficient in implementing the project, and we will also be aware of the risks that are associated with the project and thereby minimize those particular risks. Now, this is the project delivery flowchart. Now, generally, it begins from the contract signing. So after the contract signing, we go to the project kickoff meeting, which we're going to look at shortly. Now, at the project kickoff meeting, we just want to understand the requirement of the customer. Now, from the project kickoff meeting, we can now design the solution. If we are not able to design what the customer wants, then we can go back and meet so that we can be able to understand what they really want. So in case the project the customers reject what we've designed, we can go back and have meetings so that we can understand their requirement better. Now, after doing the solution design, we might need to do unpacking inspection. Unpacking inspection is when we receive the devices that are needed for this project. And when we do unpacking inspections, we might actually have what we call DOA, which is dead on arrival. That is when we receive a device and it either fails to start from the beginning or it fails within 48 hours. So we're still going to look deeper into DOA and understand how to identify whether a situation is a dead on arrival. Now, if any good has a problem, again, we have to go back and we're going to also learn how that entire process is done. Otherwise, if the devices are okay, then we can go ahead. We can go ahead and do device installation. Otherwise, if the power fails within 48 hours, you can also go back to the DOA process there. Now, after device installation, the project team needs to perform a quality check to ensure that the devices are working according to the initial design and as expected. Otherwise, if there is a problem, you again need to go back. After the quality check, then you need to do commissioning, software commissioning. This is where you're giving everything that is needed in terms of the topology designs, the configuration passwords, and any other thing that is needed, and also implement that particular software so that it begins running immediately. Then we have maintenance training. So you need to train the in-house team so that they know how to maintain this particular network. So we're going to also look at that in a short while. And lastly, on the flowchart, we have the project acceptance. Project acceptance. So here really you're handing over the entire project to the team. They're verifying that everything is as they had agreed on the contract. Then you'll be able to sign and receive what we call a project completion certificate. Okay. So let's look at each of those things that we've just looked at here. So after the contract signing, we have the project kickoff meeting. So let's have a look at this and what it entails. So the project kickoff meeting. So after the contract is signed, we hold a project kickoff meeting with the customer. Why do we do this? We want to clarify the customer requirements as it has been specified on the tendering documents and the bidding solution. Then we want to confirm the duration of the project and the entire plan of that particular project to determine the owners from both parties and the project members, to also decide the project management regulations and to confirm the device installation environment. So where you're going to install those particular devices, is the environment ready? At the project kickoff meeting, we insist that you have to check the environment. So this means the rooms where you're going to install those particular equipment. So you need to check whether they have, for example, the power that is needed, whether they have other matching systems such as air conditioning, whether the height is okay, so that you know when you're installing the racks. The racks, some of them are very tall. So is the room height okay? Is the physical security in terms of the locks and the quality of the door, is it okay? So during the project kickoff meeting, you need to check this, and the reason as to why you need to check this is so that it does not delay the project implementation at the later stages, so that you recommend as soon as possible. You recommend as soon as possible anything that might need to be done. Now, we have several documents that can guide you on how to do the project kickoff meeting and what is supposed to be looked into. So Huawei provides some sample documents which you can readily download from their website. So whenever you see such like an icon, just know that you can be able to click on this and be able to download some documents that can guide you on that particular process. Now, the next stage after the project kickoff meeting is the solution design. So here we want to compile the implementation solution based on the customer's requirements. Now, what should it include? It should include the project background and objective. These we came up with during the project design, engineering scope clarification and the responsibility division, the timeline, and the personnel that are needed for this particular project, detailed configuration and implementation procedure. So the logical topology, service migration and acceptance test. So the design should also have the quality assurance and risk control. Now, again, we have a template here that can be able to guide you in collecting all the required information that is needed for the solution design. Now, after the solution design, we now begin receiving the device, and we need to then check these particular devices. So that is part of the project delivery process. So we must check delivered devices to ensure that they are okay, they are working, the quantity is as specified in the packing list and such like things. So normally, this is how it looks like. This is how it's packaged. So that is, for example, one box, and this is another one. So when you import, this is how really they pack it. So the following information must be confirmed after the arrival of goods. For example, you must confirm the quantity of packing boxes. So for example, here we have 2 packing boxes. This is the first one, this is the second one in the logistics list. So whoever is delivering, for example, here it might be poster, who is your clearing agent and who is delivering. So you need to check whether the quantity of the packing boxes is the same as what is in the logistical list. Then you also need to check the device quantity. After opening the box, you need to check the device quantity as it has been specified on the packing list. And sometimes the packing list actually might be this particular sticker that has been stuck on the side there. Then you also need to confirm the device quantity and models. You make sure that they are the same as what has been specified on the contract product list. Now, if anything is not okay, then it simply means that the goods are wrongly delivered, and therefore you're supposed to contact the vendor so that you sort out the issue. So this is a very important stage where we need to confirm that we have everything that is needed for the implementation of the project. Now, unpacking and inspection of goods. So here we just have a template that can guide us on what to check and do the required documentation. So we need to check the parts. So when you're inspecting the goods, we need to check the part numbers, the models, and the quantities as listed on the packing list. So the other thing we need to check is whether the components are physically damaged. So in terms of physical damage, the first thing we're supposed to check is on the packing boxes. Is the packing box intact, or does it have some dents somewhere? So even before we open the packing box, we need to ensure that it's physically intact. Otherwise, we need to raise an issue even before we open that particular box. So we need to check that. Now, once the goods have been inspected and are deemed to be of the right quantity and be intact, then both the installation supervisor and the customer rep need to sign the packing list. So really, this is the template for the packing list. And these are some of the fields that need to be filled. For example, the part number, the description of that particular device, the quantity here, and so on and so forth. So you can download this document from the Huawei website. Now, we talked of the DOA process, dead on arrival. So definition is dead on arrival. So what do we mean? Expect this question most likely in the exam. So a dead on arrival, a device is physically intact upon arrival, but it fails to act properly once powered. So that's the first thing. Fails to act properly once powered. Number two is it fails within 48 hours of the device being powered on. So if either of these happens, then just know that you're dealing with a DOA. Now, the on-site engineer needs to call Huawei service hotline immediately to contact the technical assistance center for help. So you need to call immediately the TAC, the technical assistant team. So the TAC will confirm really whether it's a DOA by looking at these two. Then the on-site engineer will send the goods problem report to the TAC and obtain assistance from the TAC to complete subsequent process. So you need to report immediately. You need to report immediately. So goods problem report. So you need to fill detailed description about the goods problem in the detailed information about the problem. So you can download that particular template by clicking on this icon here. So you need to ensure that the address for receiving the replenishment goods, required arrival time, consignee, and phone numbers are all correct. So yes? Is someone saying something?
Pole, ni mtoto.
Okay, sorry. Okay, yeah. Okay, so let's move on. Okay, so checking the device, installation environment. This should be part of the procedure that you also do during the very early stages when you're doing the project kickoff meetings. You should check the installation environment so that it does not delay the implementation of the project huko mbele. So some of the things that you look at, for example, are the equipment room environment, such as do you have enough space in terms of height, length, and width, the area, the temperature, the humidity, relative humidity. So do you have them? Also closely related to the equipment room is the power distribution. So do you have the required voltage and the power current that is required to run the devices? Also, you might need to check the cabinet status, such as the dimensions, the cabling that is needed, and whether it provides for grounding to in order to be able to in order to be actually all of them, all the cabinets. So this is what we call a cabinet. All of them provide a grounding so that you can be able to discharge electrostatic voltage. So that is really what happens. And when you want to go and check the device installation environment, you might use this particular template, which I'm not showing you right now, but please make an effort to download and see some of the fields that need to be captured. So installing a device is the next thing. If everything is okay, the installation environment is okay, the device that you've received is okay, then you need to go ahead and install the device. This is normally done in 3 steps, 3 major steps. The first one is installing the device into the cabinet. Then you need to install the modules and cards into the device. Then you install the cables. So let's begin by looking at some of the things that you need to consider when planning to install the device into the cabinet. So you need to prepare all the required tools that are needed. So whether you need any screwdrivers like the Phillips screwdrivers to unscrew the rails and so on. So you need to have all the required tools. Then you need to install the mounting brackets that are going to hold your devices. Then you also need to install the guide rails. And lastly, for the cabinet, you need to install the device now into the cabinet. So most likely, the cabinet will also come with some documentation that are going to guide you, for example, on the kind of tools that you need and how you're supposed to mount the brackets, mount the guide rails, and also how to install the device into that particular cabinet. Now, once you have installed that, then you need to install any modules like cards, power modules, fan modules into the device. So after you've installed it into the device, into the cabinet, and then you can be able to add any other modules that come with the device. Then, so other than the power and pan modules, you might also need to install some service cards. When it comes to installing cables, so there are two types of cables here, power cables and data cables, also known as service cables. So power cables to power the devices, service cables to carry data and interconnect the devices together. Okay. So in checking the hardware, we normally have a hardware inspection report. So you need to perform these checks before powering on the device. Number one, you need to check the device hardware carefully based on the checklist. Then you need to perform multiple checks on the power system security. So after doing that, you need to perform the following checks after you've powered on the device. So some of the checks that you need to check, for example, is the device status indicators. So we normally have light indicators, which we are going to see, and they light up in different colors depending on the working state of the machine. So we're going to look at some of them in the coming topics. So if the device faults occur, you need to immediately initiate the DOA process in time. Remember, the DOA process needs to be dealt with as soon as the problem is detected, so that the timing, the 48 hours really does not elapse. Okay, so actually here are some of the indicators. Here are some of the indicators, for example. So you need to check the indicator status, as we said. So for example, for the power module, you have these three indicators. So you have input, output, and alarm. If they're green in color, it means they are working normally. Green in color and not blinking means they are working normally. Otherwise, if for example they are orange or they are blinking, it means most likely there is a problem. So those are some of the indicators that you need to be aware of. Most of the time, the documentation for your device will give you the meaning of each color. So SMU, SFUs will also have indicators to show you whether the device is running correctly or whether that module is working correctly. Now, other than checking the indicators, to confirm whether the device is running okay, you can also query the running status by using the display command. For example, you can type in display card status to find out if the particular card is working okay, display version to check the version of operating system that you're running, and so on and so forth. Now, after checking the indicator status, querying the running status, you now need to apply for a license. You need to apply for a license so that your device can be able to work correctly. So part of the project delivery process is what we call joint commissioning, which is normally divided into 3 steps. The first one being connectivity commissioning. So in connectivity commissioning, we want to test whether the links are working. We want to test at layer 2, is STP okay? And are we able to reach other devices on layer 2? And also we want to test whether layer 3 route interoperation is working. Are the service traffic that we've configured working based on the policies and so on and so forth? So after doing connectivity commissioning, you also need to do high availability commissioning. So for example, if one path goes down, do we have switchover? So you can do this by shutting down some interfaces and seeing whether traffic is rerouted via other paths. You also need to test what we call dual node hot standby. So for example, if you're having 2 fan modules and one of them is working on standby mode, so you can switch off the running one and see whether the one that is working on standby mode will automatically pick up. So you need to do such like tests during joint commissioning at the high availability commissioning. The other thing you need to consider is service performance. So you need to check the service traffic tests, access control tests, depending on how you've configured your policies, and also quality of service tests to ensure that the service is running as per the requirement. Now, we might also do network migration during the project delivery. The most important step in network migration is risk assessment. We need to do a very careful risk assessment before we do any network migration. So this is a high risk. This is one of the high risk network operations, network migration. So you need to check the project status. You need to try and look at why are we doing this. So the objective of the migration. Then the most important step before you do project network migration is you look at the risks that are associated with this. Now, after understanding these 3, then you can go ahead and prepare how to do the migration, then implement, do the migration, then test whether everything is okay. Now, generally, when you do a network migration, almost all the time, you might need to set up what we call a rollback plan. So that in case the network migration encounters hitches, you can be able to roll back the network at the point where it was working initially. So you must have a rollback solution. Then after doing a network migration, you also need to do a material handover. Everything that has been implemented, you need to hand over. Now, at the end of the network project, you need to do maintenance training. In maintenance training, you need to train on networking and configuration. So you need to show them, you need to hand over the topology, educate them about the topology, the interconnection. So both the logical and the physical topologies. So the IP tables, and so on and so forth. So you need to train them on that. You also need to train them on routine maintenance. So normally we're going to look at some of these things. The staff will have a routine inspection report, which they'll need to fill up, and some of the things that they need to check. So we are going to look at that in the coming slides. And you also need to train them on how to deal with emergency faults. So how can they be able to troubleshoot the network very fast and be able to return network services within the shortest time possible. So at the acceptance stage, you need to hold meetings. And in this particular meeting, you need to present the entire project. The meeting is not just an in-office meeting. You might need to go to the, for example, to the equipment room and inspect whatever has been done. So you have to go to the ground and really inspect what has been done. And we also have other procedures that are done. At the end of this project acceptance meeting, you'll have an acceptance report, and the engineering team will also be given an acceptance certificate, and that is what now really that is what marks almost the end of the project, what we call the handover. So you are able now to hand over everything that is associated with this project to the customer, so that the customer can now completely own and control their network and be able to run it going forward. So that is it about the project delivery process. We now want to look into risky operation implementation process so that we can be able to understand some of the risks that we might encounter. So as a definition, a risky operation is any operation that may affect the normal device running or a service running or monitoring of the function of the network management system. So any operation that may affect the device running, like when you talk about device running, we are most likely talking about the hardware, any hardware or even software problem that may affect normal device running. When you talk of service running, we are talking most likely about the protocols. If you're going to change any configuration that is going to affect the running of the device, that is also a risky operation. Now, if you're also going to change anything that is going to affect the NMS, and thereby we are not going to be able to monitor how the network is running, then that is also a risky operation. Now, the purpose, the risky operation implementation process is used to regulate engineering and maintenance behavior of engineers. It is also used to improve delivery quality and prevent any accidents. Now, if the on-site engineer cannot identify whether an operation is a risky operation, the engineer needs to consult the service engineers at the local representative office in time. So if you're not sure whether whatever you want to do is a risky operation, please consult Huawei, for example, at the local office, so that they can be able to advise you further. Because any risky operation most of the time requires a team to be set up, a team that involves not just the internal team, but also external consultants. So this is done so that we can ensure that we don't disrupt network services for a long time. And any risky operation, again, is normally performed during off-peak hours. Okay, so these are some of the team members that need to be there during the risky operation implementation process. So the customer, then the engineer, and then the service provider like Huawei. Now, it's normally divided into 3 steps. The solution design, then you need to obtain authorization, then you need to implement the risky operation and give feedback to the customer. So let's look at the first part, which is the solution design. So in the solution design, you need to formulate the implementation solution, then perform an internal solution review. So after you've done that, step number 3, you obtain authorization from the management. Then you perform management authorization. So each of these, you can see where they're happening and who's leading them. So like here at number 4, you need to perform management authorization. That is, the Huawei team needs to also seek approval from their own management. Number 5, you need to obtain technical authorization. These normally the engineers contact Huawei, who will then perform the solution review and technical and perform also technical authorization if it's feasible. Then the engineers will submit the solution and apply for customer authorization. So once the customer approves the solution, then they can go ahead and deliver a notification. So you need to deliver a notification and obtain on-site support from Huawei if that particular support is needed. So if that support is needed, then you need to arrange with Huawei, arrange support resources if they are needed. Otherwise, at number 11 here, you need to complete the operation and submit a service report to the customer. So the customer will then confirm that the operation are completed, and they'll submit the modified information and give feedback on the operation results to the customer and also Huawei, who are going to archive the operation materials and complete a change order and also close the entire risky operation implementation process. So generally, that is the entire flowchart for a risky operation implementation. Now, with a risky implementation process, the solution, we normally have a documentation that can guide us to implement this particular risky operation. Generally, we insist on accuracy in terms of planning and knowing that we are able to do this. Operability, in case we are having devices from different vendors, we need to be sure that they are interoperable. We need also verification support from the technical engineers and the service providers. And we also need a rollback support so that in case we run into problems, we can be able to restore the network to its last working condition. So how do you obtain authorization? So part of the risky operation process implementation was authorization, obtaining authorization. We said you need 3 authorization: management, the technical team, and also the authorization from the customer. So management authorization is based on the project situation. So the engineer will send an email to Huawei project manager to apply for management authorization. Then technical authorization, now this is the engineering team. So the engineer sends the technical solution to Huawei technical expert by email to apply for technical authorization. Then the solution must be submitted for review at least 3 days before the implementation of the risky operation. Now, lastly, you also need to find the authorization from the customer. So the customer's department that is responsible for the project construction will approve the operation with written or email confirmation. So always make sure that you get that from the customer, a written or email confirmation. Now, this is the operation process of the risky operation implementation. 7 days before, you need to finalize the solution after negotiation. And that is the documentation that you'll have for that risky operation implementation solution. So this is a template. All these are templates which you can download and be able to see some of the fields and data that they require. 24 hours before the implementation, you need to send an email notification. You need to send an email notification to the customer. 1 hour before, you need to send another notification. Then before 10 minutes, you need to be on site and you need to sign any binding legal documents that are needed for the implementation of the risky operation. So after doing that, now you can be able to implement the risky operation. After you've implemented the risky operation, you need to send an SMS notification within 1 hour. After you've been able to implement the risky operation, and also you need to send now an email notification, which is more official. So SMS is when we just want to alert and keep the customer at bar with what we are doing. But the one that is permanent and most official is the email, which you must do within 24 hours after implementing the risky operation. Okay. So let's now look at the engineer service standards. So customer information security. So for engineers, they need to uphold high ethical and integrity standards. And most of the time, they actually need to sign, for example, a non-disclosure agreement. Now, there's some information, actually most of the information of any enterprise is considered as a business secret, including and not limited to the organizational structure, the management system, the working plan, the technical materials, etc. So there's some of these things that you might be exposed to while implementing the project, but you are not supposed to reveal them. So customer business secrets, they are owned by the customer. They have legal liability, and you need to return any information after authorized use. So we forbid leakage. We forbid any illegal obtaining of the business secret or any illegal sale of customers' business secrets. So when it comes to customer information security, those are some of the things that you're supposed to be aware of and uphold. So information security on customer devices. So we are now looking into some of them. So customer device information, for example, the user accounts. Remember, you're going to be creating for them initially the device passwords, any files, processes, and data, and any important information such as the network topology, both physical and logical, IP addresses, etc., etc. So these are what we call customer device information. So let's look at this. So operating devices must be approved by the customer. Remember, for example, when you were looking at the risky implementation process, 10 minutes before you begin, you need to sign. You need to sign some authorization forms. So operating devices must be approved by the customer. So you cannot just go in and start operating devices. And most of the time, you need to sign a document for that. So that is what you're saying here. So approval record is required, whether it's an email or voice record or on-site service notification or confirmed meeting minutes. So those are some of the records, or a fax that are required for the approval. Now, the on-site engineer must explain the operational risks to the customer and try to avoid major periods, meaning that you need to do this. You need to do this during off-peak hours, and you need to let the customer clearly know the risks that are involved in this. Now, these are some of the reminders to the customer with regard to information security. So after you are done with implementing the project, one of the information security standards is that you're supposed to remind the customer to delete any accounts that were used for testing, for example. So the accounts that you might create just for testing the system. So you need to remind them to delete them. You need to remind them to update their passwords for the accounts that they're now going to use going forward, which you handed over to them. So they need to change the passwords. Then they also need to protect the log, the system log. They need to perform data backup regularly, and implementation after review. So they also, there are some things they're also supposed to implement after the handover of the project. So you need to remind the customer to do all this. So the project information security, some of the details. For example, during the project preparation phase, so project member information, so the individual members' information, on-site survey design, network planning, site information. So all these are regarded as a business secret. The project plan, the project budget. So all this information is supposed to be kept secured and protected so that only authorized people are able to see it. During the project implementation phase, things like the project-related version, the configuration scripts, the interconnection of the devices, and so on and so forth. The equipment room, anything around that, they're also supposed to be kept secret. And also during the project acceptance phase, we need to return test tools and hand over test reports that we used. We also are expected to hand over built documents, reports of known issues, and accounts and passwords to the corresponding personnel. So as you're implementing the project, you're supposed to hold high etiquette and ethics. For example, the network engineer is supposed to be good at communicating. So when you're communicating, be courteous. You need to have a serious attitude when participating in meetings. You need to be sure that any information that you're giving is correct and true to your word. Now, other than that, you also need to be well-groomed. You need to behave in a civil manner, and you need to practice a friendly and appropriate. You need to have a friendly and appropriate speech. So for the engineering team, those are some of the etiquette and daily behavior that they're supposed to practice. So on-site service behavior standards, preparation before departure. So you need to, so preparation before departure, you need to confirm the installation environment in advance. Then you need to prepare the solution, tools, spare parts, etc. that are needed to install the devices, and always be punctual. So this is the other etiquette that you're supposed to hold in high regard. Be punctual all the time. Okay, so in terms of the service implementation, we have what we call rights standards, operation standards, and attitude standards. Now let's look at the right standards. So for example, do not enter the equipment room without permission or take any prohibited article. Only work on things that are related to the project. So don't go around touching any other thing that is not related to the project. Do not operate other vendors' devices that are unrelated to the project. So on-site service behavior standards. So those are some of the right standards. Operation standards. So the operation scope cannot go beyond the scope approved by the customer. Then try to operate devices at off-peak hours. We already said this. Then take electrostatic discharge measures during operation to avoid damages to devices. So the on-site engineer is always supposed to wear an electrostatic discharge wrist so that they don't damage the devices due to electrostatic discharge. Attitude standard, we've already talked of this when we talked of the etiquette. So reply to the customer inquiries patiently. Sometimes temperatures might run high, especially when problems occur. So tolerate criticism, even if the negative consequences are not caused by you, and avoid being impolite. So sometimes the customer can really be rough, but as the on-site engineer, you are supposed to tolerate their criticism and reply politely as much as possible. So at the service completion, you need to do a face-to-face handover. There's going to be a confirmation meeting. And lastly, you're supposed to do a polite farewell. So always make sure, thank the customer for giving them a chance, for giving you a chance to work with them. Then you end that particular project that way. So that is it about this topic, ladies and gentlemen. I'll give you the next few minutes to go through these questions and just recap on that particular content that we've covered. Asanteni sana.